So today we're adding and subtracting rational numbers, and we're going to start first a little slowly and then do some warm-ups and translate that over into fractions, decimals, and some more complicated operations. But let's just use our number line for reference so that we can get through a couple of rules that we can follow. So things that we know already, but to emphasize with our number line. If I'm asked to add 4 and 5, first thing we do is we start on our number line at 4. And then it's asking us to add 5 to it. So we would go 1, 2, 3, 4, and that lands us right here on our solution because we know 5 more, and I'm going to the right because it's positive, leaves us with 9. So we know that our sum of 4 and 5 is 9. But what if we had negative 3 plus negative 2? Well, we end up doing the same operation, except this time, if I'm starting with negative 3, we'll remember that we're going 3 to the left. So there's negative 3, so it's to the left of 0, 3 units to the left. And I'm adding to it negative 2. So that means I'm going 2 to what direction? The left. So I'm going to go 2 to the left because it's negative 2. And that leaves us with our sum of negative 5. So negative 3, add another negative 2 to it, leaves us with negative 5. Let's do 2 more. So let's say we have 9 plus negative 6. What are your thoughts? First thing we do is start us off at 9, because that's 9 to the right of 0. And then I'm adding to it negative 6. That negative tells me I'm going to the left. I'm going to the left 1, 2, 3, 4, 5, 6 units. And that leaves us at 3, positive 3. And how about one more? If we've got negative 10 plus 3. So that would tell us to start at negative 10. So that's 10 to the left of 0. And then if we add 1, 2, 3 to it, that takes us to negative 7. So let's look and see if we can't find some similarities with some of these. So if I looked at, for example, the sum of 4 and 5, you'll notice that with this example, both 4 and 5 were positive values. They had the same sign. And so when we did that, we just took the sum of 4 and 5 and we were left with a positive 9. Well, let's look at this one as well. We had negative 3 plus, negative 2. And what do you notice about negative 3 and negative 2? They also have the same sign. And you'll identify that with that one, we took the sum of those two and we just combined, or we added the negative to it. So we kept that sum of negative 3, negative 2. 3 and 2 is 5, but we added the negative. Now, the other two problems, these two right here, if I looked at this one, 9 and negative 6, these have opposite signs. And you'll notice what we did here is we ended up subtracting those two. And that resulted in 3. And that number was 3 because the larger number, absolute value-wise, between 9 and negative 6, the larger number was the positive number. So that resulted in a positive solution. And lastly, with this one, our negative 10 and positive 3, those also had opposite signs, and you'll identify that we then took the difference of those two, 10 and 3. That difference is 7, but because 10 was the larger number, absolute value-wise, and it was negative, our solution to that is negative as well. So let's write this out so that we can just apply this property. So here's what we know. When we're adding, and this is going to be applicable to the integers, to the fractions, to the decimals in general. But when you're adding numbers with the same sign, so here we know they're both positive, then we're going to take the sum of those two and our result will be positive. And you'll notice here is our example. If we just take 6 and we add 2 to it, 6 plus 2 gives us 8. Whereas if we're referring to the same sign, but now they're both negative, then our approach is we still take the sum of those two, but then our result is going to be then a negative number. Meaning now if I have negative 6 and negative 2 and I add them, that results in negative 8. So we still take those sums, but then the result is a negative number. All right, then things change a little bit when we're talking about opposite signs. So here is our rule when we're working with opposite signs. We're then going to take the difference. We're going to subtract those two. And the resulting sign is going to be dependent on which of those numbers is the larger. So here's our example with 8 plus negative 2. 8 is the bigger value. And so that results in a positive 6. Whereas in this situation, negative 8 is the larger absolute value sign. So that means when we add negative 8 and positive 2, we get negative 6. I also like, just for reference, using that number line. If we started at negative 8 and we added positive 2, we would land on negative 6. So when you're working problems that have larger numbers, I'm not expecting you to use the number line here, but think about those properties, the rules that are in place for adding numbers that have the same sign and that have different signs. So if we looked at problem 1, we see that they have different signs. So what I'm going to do is subtract the 2, and that result is going to be the sign of the larger number. Which one's larger? Yup. So then let's take the difference of 15 and 11, and that gives us 4, and we would have positive 4. Great. So now let's look at the second one. They have opposite signs. So I'm going to subtract the 2. I'm going to subtract the 2 the way we're accustomed to doing. And when I do that, I end up with, to borrow from this one, 14 minus 6, 8. But I want to be mindful of which one has the larger sign, the 24, and it's negative, or which one is the larger number, and that's 24. And so my result for this one is negative. So negative 8. Check this with Desmos. And lastly, if I looked at problem 3, they have the same sign. So I'm going to take the sum because they have the same sign, and I know that my result is then just going to be negative, and I take the sum of those two, and that gives me negative 76.
I don't want us to lose sight of the fact that we can always go back to using Desmos. So I'm going to look at maybe the second and the fourth example that you see on the left of the screen. So if I wanted to check that our addition was correct, we could type in right into Desmos negative 3, I like putting parentheses around my negative values, plus, and then you'll see on the bottom right of that cell, it's already telling you what that sum is. And then the same goes for the very bottom problem, the negative 10 plus 3, and we hit enter. And so we can always use this as a a good tool just to confirm that we are in fact doing what we should be doing. Let's make sure that we're good with using these same rules for fractions and maybe a decimal or two. So let's start with the first of our fractions. You'll notice here you're adding two numbers and their signs are the opposite. So we'll start by just rewriting. I like to write mine vertically. I've got 2/3 and -2/9. So if and we're adding, and we know because their signs are opposite, we're going to take the difference and use the larger of the two numbers. So we first have to figure out which one of those numbers is the larger. So what is our common denominator? Well, it looks like we can get a common denominator of, let's see, if I multiply the top and bottom of this by 3, that gives me 9. 3 times 3 is 9. 2 times 3 is 6. And this already has a denominator of 9. That's useful. And so now we've got 6/9 minus 2/9, or I could say 6/9 plus -2/9. Either way, we're going to take the difference. And because 6 is the larger of those two numbers, we're going to keep the positive sign because 6 is positive. 6 minus 2 is 4, and I keep the bottom as 9. So this sum simplifies to 4/9. Now let's look at the second example. Example number 2 is asking us to take 6 3/4 and add it to -2 and 1/8. So these are what we call mixed fractions. We're first going to change this mixed fraction to what we refer to as an improper fraction. So let's see how we do that. I'm going to start with 6 3/4. Now you might remember from back in the day, to change this to an improper fraction, we start from the bottom and we take the product. So 4 times 6, and then that result, we're going to add that last number that's on the top of that fraction. So let's do it. So 4 times 6 is 24. That's 24. And then 24 plus 3, I meant to put a little plus sign there. So 24 plus 3 is 27. So I can rewrite this number as 27, and we keep the bottom, 27/4. 6 3/4 is 27/4. Let's do it with the second one. So this is -2 and 1/8. That negative is going to play in right after all of this. So we're just going to tack that negative back on. And then these two numbers we multiply, these two we add. Let's do it. So 8 times 2 is 16. 16 plus 1 is 17. So this, and then I bring that negative back. So now what I'm really looking for is 27/4, and I'll put plus -17/8. Not common denominators. Let's make it so. And I think maybe y'all are seeing that I can take the bottom and the top of this fraction and multiply it by 2. And that leaves us with, I don't know, let's see, 27 times 2 looks like that's going to be 54. And just so that we see it here, 2 times 7 is 14, carried the 1. 2 times 2 is 1, plus 1. Okay. So then 4 times 2 is 8. So now I have 54/8, and then I can keep this as 17/8 negative. So now I'm going to subtract those, and 54 is clearly the larger of the two. So this is going to result in a positive number as well. And off to the side, I'm actually going to do my subtraction so I can see. So I'm going to have to borrow. So now 14 minus 7 is 7, and 4 minus 1 is 3. So that looks like 37/8. So I'm going to say 37/8 as my answer here, 4/9 as my answer here, and then I'm gonna make sure using Desmos that I know how to type this in to check. So for the first one, we had 2 divided by 3, and you'll notice I'll have to use the arrow to get out of the denominator. So make sure you arrow over, otherwise you're gonna be writing everything on the bottom. We don't want that. Plus, and then I'll put this one in parentheses, -2 divided by 9. Oh, you don't see the 2. -2 divided by 9. And it's telling me that's 0.4 repeating. And remember, I can type in, I can't point, but I can put like, I can hit that button, the little numerator over denominator, and it's telling me 4/9, which is good because that's what we got. So, so this other problem, I'm gonna move this over in a second, is 6 3/4, which we, rewrote as, I think that was 27/4. So we can do 27 divided by 4. Let's do this one a couple of different ways. And then we said plus, and then negative something. Oh, here it is. I'm looking here. So we had 27/4 plus -17 over 8. Negative. So 17 divided by 8. And again, I'm going to hit the little fraction button, and it's telling me 37/8. So people, we could also go here, and if I were to write that as a mixed number, I could say 6, and then I want us to be clear about this. When we say 6 3/4, and in math language means plus. 6 3/4 plus, now here I'm going to do open parentheses, negative, and then I'm going to do another set of parentheses because I want that whole mixed number in that parentheses to be negative. I want that whole expression to be negated. So it looks like this, -2 and 1/8. And then again, if we hit the fraction button, we can see that that's 37/8. Let's polish this off with some decimal practice. So we'll look at the first problem and identify you've got -5.3 plus -4.9, same sign. So now we will add those, and the result will be negative. So I'm going to take the sum of 5.3, and since it's 4.9, we make sure the decimals line up. And then we add them right up. 9 and 3 is 12, so I carried the 1. 5 and 4 is 9 plus 1 is 10.2, and I'm almost done. Right, I need to add the negative. So I've got -10.2. Good. Here, my next problem, I've got 19.3, which is positive, plus -12.2. So in this case, I'm going to subtract the 2 and 19.3, so 12.2, and I'm lining up the decimals, and you'll notice that the 19 is the larger one, so my result here is going to be positive, since 19 is positive. And I go to town. 3 minus 2 is 1. And then 19, or 9 minus 2 is 7, and then the 1s go away. So this leaves me with positive 7.1 on a roll. So you'll notice here, got a little twist. We've got three terms. So let's just start by taking the sum of these two. They're both positive, so 0.47. Oh, and that's a 3.1. I'm lining up the decimals. Sometimes if it helps, I put a placeholder of 0 and I add those. And when we add straight down, 7 and 0, 4 and 1 is 5, and 0 and 3 is 3. So now what I can do is clean this up so that it's 3.57, because that's the sum of those two, plus now I've got negative 2.14. Well, so now those are opposite signs. So I'm going to subtract. And again, the 3.57 is the bigger, so this result is going to be positive. 7 minus 4 is 3, 5 minus 1 is 4, and 3 minus 2 is 1. And here we can probably much faster just confirm we're doing the same thing, where, and I'll put that in parentheses, that we're in fact correct. So we can check all of these plus negative 12.2. We can check all of these on our Desmos, and the last one we can just do all of those in one step. 0.47 plus 3.1 plus negative something, 2.14. And then we leave these in decimal form since it was presented in decimal form. Now we're moving on into subtraction, which you will see there's a lot of similarities. With subtraction, it's the opposite. We're taking away. You add something, I have 3 bunnies in my hand, I add 2 more, I have 5 bunnies. But if I have 3 bunnies in my hand and I take away 2 bunnies, I now have 1 bunny. So it's elementary, but I think sometimes with the negatives and positives, it can get a little tricky. So let's go to work on these. Let's look at the first example. You've got 6 minus 10. So similar to what we did with our number line, we would start at 6, but now they're telling you to take away 10. So we're now going to go 10, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. So 6 minus 10 leaves us with negative 4. So we would end up with negative 4 in our placement. You might be comfortable in identifying 6 minus 10 is also the same thing as negative 10, because that negative is attached to that 10. And what is this 6? Is it positive or is it negative? Well, there's no sign in front of it, so we know it's positive. It's implied. So that would have been the same operation as what we had done previously, so we could think of it that way as well. So 6 minus 10 would be the same thing as negative 10 plus 6. Still gives us negative 4. So let's look at problem 2. Now, when you see minus a negative, so you've got negative 8, then it's minus negative 4. A negative on the outside, this typically means times. A negative, that becomes a positive. A negative times a negative is a positive. So this would be the same thing as negative 8 plus 4, because you've got minus a negative. A negative times a negative is a positive. There's a movie called Stand and Deliver where the, oh my God, I'm going to show it.
A negative times a negative equals a positive. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Again. A negative times a negative equals a positive. A negative times a negative equals a positive. I can't hear you. A negative times a negative equals a positive. Louder. A negative times a negative equals a positive. Louder. A negative times a negative equals a positive.
So if I'm treating negative 8 minus negative 4 as negative 8 plus 4, I would then go to negative 8, that's my start, And then I would add 4 to that. So we'd go 4 to the right. And that leaves us with -4. We can also just use our rules from previously. You've got a -8 and a +4. So we would take the difference and the result would have the sign of the larger number. And here's 3. 6 minus -2. A negative times a negative is a positive. Boop. So then that gives me 6 plus 2. And that one's a little clearer. That's 8. And then 4 is our tried and true, what we used to see back in elementary school. We've got a 10. We're subtracting 4 from it. 10, take away 4, leaves us with 6. So let's see this in action. So we've got -3/5 minus -4/15. A negative times a negative is a positive. So I'm rewriting that as -3/5 plus 4/15. So that 4/15 is positive, that 3/5 is negative. So we've got -3/5 plus 4/15. So here we want a common denominator, and I think we can make both of those bottoms be 15. If I did what? If I took the top and bottom of that top fraction and multiplied them both by 3. -3 times 3 is -9. 5 times 3 is 15, and this one is still 4/15. So now I have -9/15 plus 4/15. Remember that denominator doesn't change, so that's going to be 15. -9 plus 4, the signs are opposite, so I take the difference of those two and I keep the sign of the larger number. So 9 minus 4 is 5, and since 9 is the larger one and it's negative, my answer is -5/15, but I can reduce that because those two numbers have something in common. What's that common factor? It's 5. 5 goes into 5 once, so 5 divided by 5 is -1, and then 15 divided by 5 is 3. Bloop. So that's my answer for the first one. Now let's look at the second. So that's 5 1/3 minus 4 2/9. So I'm going to do what we did on the last problem with the mixed fractions. I'm going to turn that into an improper fraction. And remember, that's 3 times 5. That's 15 plus 1. So I can rewrite 5 1/3 as 16/3. And then 4 2/9. 9 times 4 is 36. Plus 2, 38/9. So now, and what am I doing? Oh, I'm subtracting. I'm subtracting here. So 16 over 3 and 38 over 9. So minus 38/9, common denominator. And here it looks like, man, 3 is popular. I can multiply both the top and bottom by 3. 3 times 3 is 9. 16 times 3 is 48. But let's just do that up here. So 3 times 6 is 18. And then 3 times 1 is 3. So that's how we get our 48. So now I have 48 over 9 minus 38 over 9. The 9 doesn't change. That's the denominator. And now I've got 48. Take away 38. Leaves me with 10/9. And the last one. Oh, that last one is a little bit of a twist. We have -6 minus 2 1/3. So here I am subtracting 2 1/3. And there are some books that tell us, which and it's true, I can write that as -6 plus -2 1/3. But I am subtracting 2 1/3 from -6. So let's write -6 as a fraction since we're in this fraction mode. And then let's take that negative 2 1/3 and write it as an improper fraction. So that's 3 times 2, which is 6, plus 1, which is 7. So I keep the denominator. So that's 7 over 3. So now I have negative 6 over 1 minus 7 over 3. And that looks like common denominator is going to be 3. So that means I'm going to take this top and bottom, multiply it by 3. So negative 6 times 3 is negative 18. 1 times 3 is 3. So I have negative 18 minus 7, negative 18 over 3 minus 7 over 3. Same signs, so I'm going to take the sum. So I have 18 plus 7, and that is negative 25 over 3. And then we're going to use Desmos to validate all of our work. So let's start with the first one, negative 3 over 5. And we don't have to do this with all of them. Now that you know how to plug them in, minus, I think it was negative 4 over 15. And then remember, I can hit the little fraction on the left that's highlighted in blue. And when I press that, it should give us what our solutions are. Here are the last three, and we can do these quickly. These are just some decimal examples. And from this, we can see, just starting with the first one, we notice that the signs are the same for both of those numbers. That 6.24 is negative. That 8.52 is negative. So, and again, if it helps, you can write it as plus negative 8.52, but I think maybe if you just see it from here, you know I'm going to take the sum of those two, and my result is going to be a negative. So I do my arithmetic vertically. So then when we add those two down, we get 4 and 2 is 6, 5 and 2 is 7, 6 and 8 is 14, and we keep the negative sign. So we know that that is our answer, negative 14.76. Now for this one, a negative times a negative is a positive. It's actually 11.1 plus 3. So I'm just going to write it like this, and I'll put it as plus 3.0 so that we've got our decimals lined up, because 3 is the same as 3.0. 1 and 0 is 1. 1 and 3 is 4. And then I bring down the 1. And that's our answer for the second one. Go back to Desmos and check these. Make sure you're putting it in properly. Now here, I've got a positive 1.8 and a minus, so negative 7.9. So I've got all opposite signs, so I know I take the difference. So I'm going to subtract those two from each other and keep the sign of the larger number, which is going to be negative, right? Because it's 7.9. So 9 minus 8 is 1. Our decimals line up perfectly. And then 7 minus 1 is 6. But then that answer is negated because the 7.9 is the larger number, and it's negative.